Wow, and we are live. Welcome, all my viewers. If you're just coming in, I hope you're ready for an awesome study stream. The current stream bitrate is quite low. However, that doesn't matter, for nothing can stop the study grind, except for Tetris. But yeah, let's get into it. Topic 6. Force on. On a small point mass. Interesting. I feel like that's wrong.
Anything worth doing in life has risk. As an astronaut, that sort of becomes your life. I decided a long time ago that exploring the rest of the universe was worth taking a risk for.
And then I'll put a dot point to make it more clear to the examiner. Show that for Mars. K is a we'll just write this, I guess. Oh, that's a thick pen. I was using that to draw the thumbnail. Oh, that's quite thick as well. What a pleasant surprise, one might say. We'll look at the data book. So t squared is also the same as 4 pi r over t squared. So I'll just do this on the side. Over t squared, and we'll rearrange this for t squared. So this becomes yep. Yeah, we're gonna need mass, so let's do a force, so we get because MA which equals M times A for pi r over t squared. And this is also equal to G M over r squared. So we're going to move times this cubed is equal to 4 pi times m divided by gm over m. This allows the masses to cancel out, thus giving us k to be equal to this. What an elegant solution, if I do say so myself. So yep. And 4 pi over gm, we know all the values, we know mass as that mass, so we'll write g, and g will be given in the data booklet, possibly as almost the first constant, the second constant, in fact, 10 times 10 to the negative 11. Yep, and then we know that the mass of Mars is 6.4 times 10 to the 23. And and this will give a value of k. Which so 2.9 times 10 to the negative 13. And since this is 3 marks, I'm scared that they might need units as well for this answer. So we know that 4 and pi are unitless. And what is G? G is newtons per meter kilogram. Yep, so there's units just in case. So what we go into is V orbit, which should be hiding in data booklet somewhere for us. V orbit, very nice. So, but we don't know what R is as such. We will need to. Is it equal to T squared over K? We will pray that this works. Because I don't know if the R that they're talking about is equivalent. Whatever, we will see how it goes. GM. G is and M is just equal to 6.4 times 10 to the 23. Cube root of T squared, so K, and K was calculated in the previous question to be this. Let's go 3.6. Oh, that's oddly fast. Considering it is faster than the speed of light. One would be worried about the answer given. Quite the worry to have such a value. Did I put t squared at the top of this? Yes, I did. How silly of me. Ah, that's more lovely. So, one. We shall just copy and paste. Can we copy and paste like that? I wonder what happens. Ooh, no. We shall not. I would normally write this in if it were an exam. However, this is not the case. Okay, we should get an answer of about 2400, I think. Or 18, not 24. Then we'll divide it by 4. Right? Ratio the distance of Mars from the Sun, distance from feathers. How is distance proportional to R over intensity though? I is power of area. We have a solar constant that's given in the data booklet. We'll just work backwards from there, I guess. .36 times 10 to the power of 3. It does say intensity is proportional to A. Is this amplitude? I reckon this is amplitude, so we'll stray away from that one. And here, anything on intensity? Not really. Intensity is power of area. So surely this is P over the area. Whatever, we can just close like 4 pi r squared anyway. So we will rearrange for r. Kind of like that? That doesn't feel right. What's gonna cancel out here? I don't think we want intensity, we just want a power and a radius. Less increases for us. Nope, we're in the wrong topics. So it's option D? Nah, doesn't sound like anything useful. I wonder. I guess we can still try to solve what we have. So I just times it by surely the p's cancel out since it's still a solar constant. It wouldn't tell us, would it? No, it does not. maybe the intensities are the same? And the power cancels out. Something like that. That doesn't sit right with me. Not a lot of it does. Let's just work backwards, I guess. We'll go 600. Value. .36 times 10 to the power of 3. Divided by 2 full zeros here. Maybe we'll square root this. So that's what it seems to be heading somehow. Maybe not. Maybe we'll square it, I guess. What the heck? We'll leave it at that. I really care. That means surface temperature of Mars. Assume that Mars acts as a black body. I'm gonna assume that Mars acts like a black body. Sounds like a topic 8 question. Yeah, one of these. Or is this the question? 800 divided by sigma area. Oh, P is also equal to I times A. Wow. How do I get this? Is the temperature. What? I guess. No, the A's cancelled out, I remember. Sick. Well, if we get 320 Kelvin, and it's telling us Mars is not, do we divide it? It's ours. Ours like 300 Kelvin. I put a lo-fi. How is this lo-fi? How dare you? Wow. How dare you? I guess we'll just have to find. Yo, that's my stream. What do I? I'm gonna go lo-fi K-pop again. Let us pray. So we clicked on this one before. So maybe this one will not have like words in it. Those don't sound like words, which is good to hear. With a twin MF capacitor and a battery and a school experiment. The switch is connected to wire. The capacitor fully discharges through the electric motor that raises a small mass. Well, I think this is a 1 markers. Theoretically, it should not be too complicated. Topic 11, I would say C times V equals Q. That's not what we want. 144. I'll just write coulombs for now. The motor can transfer 1/3 of the electrical energy stored in the capacitor into gravitational potential. So, how is energy equals half CV squared? That's good to hear. And we'll times that by 1/3, which will give us the capacitance, which is 1.6 times 10 to the -3 times 9 squared equals mgh. And this will give us, I guess we will just write it for now. Times 9 squared. Oh, and we have to times that by 1/3. Zero point 0.0216 over 85 grams, which is 0.085. And G is just 9.81. That shall give us our height. So it's 2 centimeters. Okay. Sounds okay. Put meters here. additional identical capacitors connected in series with the first capacitor, and the charging and discharging process are related. Identical capacitor is connected in series with the first capacitor. So we are given series. So 1 over C is equal to C1 plus 1 over C1 because it's identical. Thus, the total capacitance becomes 1 over 2 over C1 to the power of negative 1. So, the capacitance is halved. Capacitance is halved. So, the height and the time it takes to raise the 85 gram mass. So time is proportional to Q, and C is proportional to Q. So we can on the height, whatever. So how is C proportional? C is proportional to H. Yep. Therefore, height is half. What's the height? 0.026 becomes 0.013, and C is proportional to the time to. How is that proportional? We have less capacitance. We can just work out the time constant. So we know tau is equal to RC. So tau is proportional to C, and C is halved. Therefore, time constant is halved. Therefore, half the time. Would it take longer? No, just to be sure. Calculate the radius of a carbon 12 atom. Wow. Wow. Okay, well, we shall go to the Fermi radius. This is given by this, and A is, I'm guessing, the number of atoms in the nucleus. So R will equal R0. This is known as the Fermi radius, I'm pretty sure. We will look at the Fermi radius, 1.2 times 10 to the negative 15. times A. So A in this case is either 12 or some other number. In this case, but like it's too easy if I just do that. Let's check on the periodic table if there is one in the data booklet. No, why would they include a periodic table? That is true. I feel like Z is the number of protons and A is just a number. So 12 does seem okay in this particular situation. Thus, I will leave this as 12 and calculate the radius using it. Whoopsie daisies. I guess. In an experiment to determine the radius of a carbon-12 nucleus, a beam of neutrons is scattered by a thin film of carbon-12. Variation of intensity of the... So let's draw this out. Nice. So this is just a first fraction thingy. This is a graph. The radius of a carbon-12 nucleus. Sine angle is kind of equal to lambda over d. Do we have lambda? I guess. Is this d the right d though? Yes, it will have to be suffice. So this will give us the diameter, I'm guessing. So we'll just divide that by 2. So 2r.
Eric,
will equal. Sabavia?
guess what he said?
She said?
She said we did cover this in class. It's in the PowerPoint for 10.1.
Yeah, I said we did cover it in class.
On the summary sheet attached, which you were to complete when we did topic 10, you might remember that I said you need to name everything up to the thick line. You should also be aware that ETH is a structure. As for diols and dicarboxylic acids, the guide is not so clear on that. I have seen diols on exams. I can overview that in class next week. Okay.
Yeah.
So basically, everything that MSJ Chem is teaching, we need to know.
Well, MSJ Chem does teach IB, right?